Hello geometry, and welcome to another very short week. So I look forward to getting together and working through this with you virtually on a Google Meet. But in case you weren't able to make it to that Google Meet or you have additional questions, today's notes explaining the content will actually be going through the practice itself and explaining how to work through the problems. So this is going to be its own answer sheet and notes all in one. And so what we're looking at is how do you perform a translation in geometry, and we're answering that through our 3-2 practice. So, ladies and gentlemen, let's go ahead and work through the practice. First, question 1. The rigid motion that maps the dotted line figure to the solid line figure is a translation. True or false? First things first, let's talk about rigid motions one more time. So, question 1, rigid motion. A rigid motion is a transformation that maintains the shape and size of the image to the pre-image. So that preserves is a better word to use. A transformation that preserves, and if it's going to maintain or preserve the size and the shape, then what we're really saying is the distance and angles of the pre-image. Because remember, the pre-image is the before, the original, and the image is the after transformation. Next, the word maps here is one that's not used or thought of very often colloquially in reference to math. And so when we talk about maps in English, what we're really talking about is a thing that shows us where to go. That's the same application in geometry. If something is mapped, then it's showing us where to go point by point. And so when we talk about the rigid motion, we're talking about the transformation. And the type of transformation tells us where each point goes. So this point right here is mapped to this point right here. And we know that because of the type of transformation. Now, we're going to be getting into what that transformation is here in a second, but you can tell that this shape right here looks the exact same as this one, just slid a little bit over. And so each of these points, to help illustrate what this word maps means, each of these points on this shape is mapped to the other one. We can follow, like on a map, where each point goes to know how each point corresponds. And remember, corresponds just means to match. So, last but not least is describing what a translation is. And that's what I was referencing earlier. In case you haven't heard already, what is a translation? A translation is a rigid motion that I'm going to use the SLIDE slides the pre-image along a vector. Ooh, use another big word, vector. So a vector essentially just means the location to where it's going. So a translation is a rigid motion that slides the pre-image along the vector. Well, it's just the slide. And then where it ends up is described by the vector. And so, as an example, to help illustrate this first, if I have this shape right here, and I draw a vector, the direction that the arrow is pointing and the distance of the arrow tells me where the new shape is going to be. And so the new shape is going to be exactly where that arrow pops up. Pretend like those are exactly the same. So that arrow is the vector. And a vector is a distance and direction. So, a rigid motion is a slide that moves the preimage a certain amount of distance in a certain direction. So, ladies and gentlemen, is this a translation? Well, yeah, look, it's the exact same shape, slid over a little bit to the left, or I guess in this case, yes, that would be your left as well. So, this shape just slid over a little bit to the left, so that is true. Question 2. What is the coordinate of G prime? So here's our shape, F, E, G. What is the coordinate of G prime if fun notation of our triangle to more notation? Oh my goodness! Ladies and gentlemen, let me help you out with this notation and explain question number 2. All right, ladies and gentlemen, so let's talk about the notation in question number 2 here. First, the T here represents translation. And so that's what that T means. It's notation. It's a shortened version for translation. And ladies and gentlemen, the thing that's fun to know is that how vectors are described. And I'm going to use the word notated. So basically how they're written is with a pointy bracket, X, comma, Y, pointy bracket. So all that means is essentially how far on the X and how far on the Y. So let's do some application with that. In this example, we're talking about how far on the X and how far on the Y for our translation, which they give us being the 8 and the -5. Now I'm doing the 2 different colors there to help illustrate the difference with our X distance and our Y distance. Now, ladies and gentlemen, if you Google search this, you will notice that there's other notations that they use out there. And so we can talk about those other notations at a different time, but the primary introduction, especially for the limited time we have, we're going to be using for this unit, this bracket notation with the capital T there to help essentially identify that it's going to be a translation. And so if I read this sentence right here with some more clarity, essentially, what is the coordinate of G prime if we translate 8 units in the X direction, -5 units in the Y direction for our triangle to get our image, or our pre-image to get our image? And so, ladies and gentlemen, a vector can be drawn, because remember it's just an arrow, a vector can be drawn literally anywhere, because it's only talking about distance and direction. And so talking about going 8 units down from this point, or sorry, not 8 units down, 8 units to the right from that point, and then 5 units down is going to be the same distance and direction literally anywhere on this grid, right? It won't have the same location. It won't end in the same spot. But a vector doesn't talk about where it ends. It talks about how far you're going and the direction you're going. And so if I look at G and I want to talk about going 8 units to the right, then I'm going 1, 2, 3, 4, 5, 6, 7, 8. So that's 8 units to the right for our vector. And then I'm going to go 5 units down. And the reason why I know it's down is because the 5 is negative. So I'm going 1, 2, 3, 4, 5 units down. And ladies and gentlemen, the arrow I draw to match that will go from G to our new spot, which will be G prime. And that G prime is the end of our vector, which also means it's the end of our translation. It's where we go for our shape. Now, I've just drawn essentially what looks like a triangle there, and the reason why it works is because we're on a graph, we're on a coordinate grid, and all things on a coordinate grid can be explained by talking about our x and y separately, talking about going x first and y second. That's how slope is defined, right? Rise over run, the change in y first and the change in x second. So, ladies and gentlemen, just to illustrate this for the rest of the shape, we're going to be moving the rest of our points by that same vector because it's all the same translation. So, for f, we're going to count 1, 2, 3, 4, 5, 6, 7, 8, and then we're going to count down 5. 1, 2, 3, 4, 5. So right there is going to be our f prime, and then E is going to look the exact same. And if you notice, my shape is kind of looking a little bit messy because of the amount of work I'm doing on my paper. And so that is okay. Once you draw your points, you can use the eraser function. Uh-oh, I didn't mean to do that. That was a little bit too much erasing. You could use the eraser function to kind of clean up your paper a little bit. And so I'll go ahead and count without necessarily drawing here in order to plot my point E. So point E is going to go 8 over 1, 2, 3, 4, 5, 6, 7, 8, then down 5. 1, 2, 3, 4, 5. And so that is where E prime ends up. Now, ladies and gentlemen, connect your points. We're going to go ahead and use orange here because orange is a great color. That is our image. The image is after the translation, pre-image is before. So, talking about the notation, ladies and gentlemen, the pointy brackets just help identify that you're talking about a vector, and the vector is how we're sliding, the direction and the distance. And the whole shape, point by point, is sliding by that much. And the T illustrates, just telling us is going to be a translation. Starts with a T, so we're using the letter T. And then everything else is just saying from our pre-image to our image. And it's helping us name it by giving us the letters with the primes on them. And so, ladies and gentlemen, if you didn't already notice, because I only noticed for the first time here, that is a typo. Perfect. All right, ladies and gentlemen, we're going to talk about question 3 in the next video.